All right, today we're going to start talking about circles, and we're going to spend the rest of this 9 weeks on circles. Today we're going to become familiar with what the equation of a circle looks like and how to graph a circle. This is in section 12.5 of your book, lesson 53. So what we want to do is be able to write the equation if I give you the center and radius, or if I give you the graph of a circle, you should be able to write the equation. And we also are going to be able to look at the equation and use it to actually graph the circle. Okay, a circle is a set of all points in a plane that are equidistant from the given point called the center. Here is my center. The center is a single point. And every point on this circular path is a point on the circle. Each one of them are the same distance from the center to the edge, from the center to the edge. And we're going to find out on the next slide, what do you call that equidistance there? So radius and diameter, we're familiar with these because we talked about them when we were doing area. The distance from the center to a point on the circle is called the radius of the circle. See how that's marked there? And the distance across the circle through the center is called the diameter. And we know that the diameter is twice as long as the radius. Now, when we are working with circles, we really just need to know the length of the radius, because that's that equidistant from the center to a point on the circle has to be equidistant. Now if I told you what the diameter was, then you would have to half that so you can find your radius. When we were doing area and circumference, radius and diameter meant the measurement of the length of the segments, but radius and diameter can also describe segments. So I want to talk about one thing before we talk about radius. A circle is named by its center. So if I want to name a circle, I use a circle with the center located. And then the name of the point that is the center is used to name the circle. So this circle has a center at point Q, so we'd write this symbol Q, and we would read this as circle Q. Radius. A radius is a segment whose endpoints are the center of the circle and a point on the circle. So radius is what we're going to be using today, from the center to a point on the circle. And hopefully you can see in this slide that from Q to P would be a radius, from Q to R would be a radius, and from Q to S would be a radius, and the plural of that is radii. So these are segments, so I put bar marks over them, and all of the radii of a circle are congruent because they are equidistant from the center of the circle. Now you can write an equation of a circle in the coordinate plane if you know its radius and if you know the coordinates of its center. So here's the circle, and it's going to have a particular center, and then here's the radius. So if we could find out what that length of that radius is, and if we could know where the center of the circle was located, we could write the equation of the circle. From this point forward, they're going to always identify the center with the letters HK. H represents the first number in the ordered pair. K is representing the second number in the ordered pair. We have one theorem for today. It is theorem 1216, and it's very simple. It says an equation of a circle with center HK, we have to know those two numbers, and radius R is. That's all you have to know to write the equation, is the center and the radius, because the definition of circle said it's equidistant from a given point. The given point is the center, and that distance is the radius. So we're going to say x minus h, that's going to be enclosed in parentheses. We're going to square that. Plus y minus k, that's enclosed in parentheses, squared. And then on the right side, it is the radius squared. So what we're going to be doing is taking this number from right here and plugging it in, taking this number and plugging it in, and the radius would go into here. These will be numbers that plug into this equation so that we can produce a unique equation for any circle that we would be talking about. All right, so we're writing a standard equation of a circle. These are our numbers. H is our 5, 0 will be our k, and of course our radius is 2. So the first thing I'm telling you is to determine what your h, your k, and your r are. H is 5, k is 0, and your radius is 2. The first number is your h, that's alphabetical. Second number, k, alphabetical order for all of them. And radius is 2, HK2. As you're seeing it here, they're plugging in an alphabetical order. That's how I think about it. All right, next, let's see what they're asking us to do. They're saying use the equation. This is the only equation for this lesson. It's x, please remember that's minus h, square that, y minus k, square that, equals r squared. So if you know that equation, all you're going to do is plug in your h, your k, and your r. These are going to turn into numbers. So I'm plugging in that 5, plugging in that 0, I'm plugging in that 2. Now this is not acceptable form because I can simplify part of that. I can't simplify this, but there's no need to say y minus 0 because that's just y, and 2 squared, we would never leave that as 2 squared. We know that's 4. So all we've done from this step to the last step is simplify. Can't do anything with this one. Y minus 0 is just y being squared, and 2 squared is 4. If you can identify your h, k, and r, and you know your equation, you've got this. All right, here's a second equation. We know the center is negative 4, 1. We know the radius is 7. That's all we need to know, plus the equation. Here's the equation. Does everyone understand where this is your h, this is your k, and this is your 7. So we're going to see a step where those are being substituted in. There we see. Now this one's a little bit tricky because this is minus a negative 4 minus a positive 1 and 7 being squared. This is going to stay as it is. There's no need to simplify that. This has to be simplified and this one has to be simplified in the next step. So they're telling us to substitute our values in, which we did, and then lastly we're going to simplify. Subtracting a negative becomes plus a positive, stays as it was, and 7 squared is 49. So there we just simplified. We started with our standard equation, we plugged values in or substituted values in, and then we simplified. Let's look here. It says write the standard equation of the circle with the center at 3, negative 1, and the radius 5. You got to know this equation. There it is. So we are going to take that 3 and plug it in for our h. We're going to take that negative 1 and plug it in for our k, and then 5 is our r value. So you should know what to write for your next step. It should be x minus 3, that's being squared, y minus a negative 1, that whole difference is being squared, and then 5 squared. We substituted, and we know how to substitute. Then we're going to simplify. Hopefully everyone realizes this part has to simplify as well as 5 squared. The first part doesn't. It's fine just the way it is. minus a negative becomes plus 1, and 5 squared is 25. So I think we've done enough of those examples that you've got that. All right, now what if I give you a graph? You should be able to determine the center of this circle, and you should be able to determine the radius of this circle. Okay, so let's see. Before I start counting here, I noticed something peculiar about this graph, and it's not marked off in units of 1, it's marked off in units of 2. This is 2, 4, 6, 8. So every time I move a block, I'm really moving 2 units. So this is 2, 4, 6, 8. Now we're actually moving to the left from our origin. So we're going to go 2, 4. That's negative. So it looks like my center is going to be negative 4 in a minute. And then I'm moving 2, 4, 6 down. So I think that's going to give me a center of negative 4, 6. And then we have to count our radius. Now, if you want to count your radius, you either have to go horizontal from there or you have to go straight up. You can't go sideways. So if I want to go and count my, let's say I want to go in here and count my radius, make sure you're starting at your center and you're counting in a horizontal direction. That's 2, 4, 6. Even this way it's 2, 4, 6. So I think my radius is going to be 6. All right, now remember that equation. That equation is x minus h. Oh, and I have a typo right here, y'all. This should be y. So sorry, I did not know I had a typo. That should be a y, so make sure you change that on your paper. So I am substituting x minus a negative 4, so that becomes plus 4. I'm substituting minus a negative 6, so that becomes plus 6. And then I have 6 being squared. And let's correct our mistake right here, or my mistake. That should be y right there. So x plus 4 squared, because subtracting a negative becomes plus 4. Y subtracting a negative 6 becomes plus 6. And 6 being squared becomes 36. All right, if we're going to graph circles, we only have to know 2 pieces of information. We have to know the center and the radius. Circles are all about the center and the radius. So before we try to graph circles, we're just going to do a few little exercises of finding the center and the radius of a circle. Okay, and again, this is the equation. This makes up my center, and the number being squared here is my radius. So if I have the equation, the square of x minus 3 plus y squared equals 49, what would be the center? We have to think about what was being subtracted here, what was being subtracted here, and what was being squared over here. Well, what's being squared is 7. I think it's obvious what's being subtracted. So what's being subtracted in that case is a 3. What's being subtracted here? Absolutely nothing. And what is nothing? 0. Now remember, what is being squared here? The number that's being squared is your radius. So your radius is not 49, but 7. What was subtracted from your x is your h, or your first number. What's being subtracted from y is the number 0. Nothing is being shown subtracted, so you have to imagine that it is really like this, y minus 0. And then what was squared to get 49? 7 was squared, and so our radius is 7. Here's another problem. We have x, the square of x plus 7. we have plus the difference, the square of y minus 3 is equal to 10. I don't want to forget that this, 100. This is 10 being squared. So I understand that what's being squared, my radius here would be 10. Right here, I am looking for what is being subtracted. Now this is the part that's confusing. When you see a plus sign, it's because you were really subtracting a negative number. When you see a plus sign, you have to remember that you were subtracting a negative 7. What's being subtracted here is a 3, and we understand what our radius is. So when you ask me what my center is, when I see that plus, I was really subtracting a negative 7. There's my 3 that's being subtracted. And what did I square to get 100? I squared the number 10. If you can do those two skills, finding the center and the radius, then you can graph a circle. Graph the circle, and again, there's that equation. We cannot get away from that equation. That's the gist of this whole lesson. It says that I have the equation of a circle, and it's given the square of x plus 2, the square of y minus 3, and the radius. And so you need to rewrite or rethink this so that you can find the center and the radius. So I'm thinking about it this way. It really is x minus negative 2 since I had a plus sign there. So that really is x minus negative 2. This is y minus 3. And 9 is really 3 squared. This number is my radius. This number is my k. This number is my h. I kind of did that backwards, sorry. So my center would be negative 2, positive 3, and the radius is 3. That's what I need to know in order to be able to graph. Now, if we want to graph a circle, the first thing you're going to do is plot the center. So if you go back and look, our center was at negative 2, positive 3. So the first thing I would do is go here to the origin and plot negative 2 is 1, 2 to the left and up 1, 2, 3. So I'm right here for my center. You're counting from the origin the way you normally would. 2 to the left and 3 up. This is the important point, which is the center. Now, if we were in class, we would all be using compasses. Remember when we used the compasses when we were doing the triangles and drawing the circles inside and outside the triangles when we were doing circumcenters and incenters, but you do not have a compass, so you're just going to have to do the best you can do as far as sketching one by hand. And this is how you would do it. Your radius is 3 units. So you're going to count horizontally 1, 2, 3 units. So your circle's got to touch there. You're going to count up vertically 1, 2, 3. So your circle would touch here. 1, 2, 3 horizontally to the left, and 1, 2, 3 vertically down. So these are points that you would, and you're just going to do the best you can do drawing a circle. And I'm drawing it with a pointer. I think I could do better. When you're drawing a circle, it's very deep out. Some people may try to make it too shallow in here. It seems like it's almost touching as you go around in here. See how close it is to the sides there? So do the best you can do. I understand these are difficult times. All right, we're going to do one more problem. It says graph the circle that has this equation, x minus 2, the square of that, y plus 3, the square of that, equals 16. And remember, in order to graph, you have to know 2 things. You have to know the center, and you have to know the radius. So we're going to rewrite or rethink of the equation in our heads. So that equation, the square of x minus 8 plus the square of y minus k equal r squared, that's where we're headed. So our equation originally was this. We're going to rethink about this middle part right here as minus a negative 3 because that's the number that's important, and we're thinking about 16 as what did I square to get 16, and that was the number 4. So when I say rewrite or rethink about your equation so you're coming up with the correct values for h and k and r. So the center here is what's being subtracted is that 2. What's being subtracted is this negative 3, and what was being squared was the radius. So that's all we need to know, the center and the radius. So we're going to go back and try to sketch a graph of this circle on the coordinate plane. So here's our center. So it was 2, 1, 2, 1, 2, 3 for negative 3. You got to put that center in there. Go back to your center, and your radius is 4. So that means you're going to count out 1, 2, 3, 4. Just put a little dash there. Go back to the center. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Go back to the center. 1, 2, 3, 4. Okay. And so 1, 2, 3, 4 from your, so I went to the left, I went up 4, I went to the left 4, and I went down 4. I don't know if I said right or left, but I went right, up, left, and down. So just do the very best you can do trying to draw a circle around there. And I think I could probably do a little better if I went back and tried a second time. So the effort is what matters here. So I think I would try again. I think I could do better than that. But do the very best you can do. I'm understanding that we're not in the classroom, and we don't have the compass that we would normally have. So we are doing the best that we can do. So that's the conclusion of this lesson.